All right, so next up we have another hockey talk. So this project is being advised by our own Sam Ventura from the Buffalo Sabres. So we have Ian Pérez, Fritz Sanger, and Christina Vu. Ian and Fritz are in person today, and Christina will be joining us over Zoom. So Ian is a senior at Arizona, pursuing a dual degree in math and Spanish and translation with minors in sociology and data science. Outside of academia, he's passionate about sports and social justice. He is the VP of the University of Arizona Sports Analytics Club, and he is interested in applying statistical methods to social science. And after graduation, he plans to pursue a PhD in statistics or sociology. Fritz is a junior at CMU, pursuing a dual degree in statistics and machine learning and business administration with concentration in finance. He's passionate about work in the intersection of quantitative sciences, computer science, and applied areas such as sports and finance. And finally, Christina is a senior at TCU, studying math and economics. Her current interest is in Bayesian statistics and application to sports and data-driven decision making. And after graduation, she plans to pursue a PhD in stats and a career in quantitative research. Outside the classroom, she is a volunteer pianist who enjoys hearing her love of music with her community. So guys, please take it away.
All right, hello. Hello, everybody. My name is Fritz Sanger.
I'm Ian Pérez.
And our third teammate, Christina, is on Zoom.
Thank you, Fritz.
And we are here to present today our project evaluating killer defense, evaluating individual defensive contributions on the power play, on the penalty kill. So at the start of our project, we wanted to analyze what leads to success on a hockey power play. As we went on, we narrowed our focus to what things impact pass success rates, and further, we analyzed which defenders were the most disruptive of pass success rates on the penalty kill. Our data was from the 2022 and 2024 Big Data Cups provided by Stathletes, and it contained play-by-play data for 29 international women's hockey games and tracking data for the power plays of six of these games. In the end, we wound up using cleaned data from Alone Harrell, Robin Ritchie, and Phil Shreve's 2022 Big Data Cup submission. So this here is some plotting of some of the passes included in our event data. This is just a small subset of the passes. It's passes following a puck recovery. That is just to make the visual easier, as otherwise it would just be a screen of fully filled in black lines. And so we decided that it would be helpful to break down these passes into types. So we ran a clustering algorithm. So we ran k-means clustering with k equals 10 in order to get more insight into the different types of passes that were being made. We made this not just on the power play passes, but on all the passes that we were provided. But in our EDA, we saw that the vast majority of power play passes occur in the offensive zone. So these were the clusters that we were most interested in, with D to D passes, D to F passes, cross-ice passes, possession passes, and offensive regroup passes. From here, we looked to build a model that analyzes pass success probabilities, and we wanted to view which factors have the greatest impact on pass completion percentage. So the features that we built and used in our model were the type of pass pattern, which we just saw. Those are like the D to D passes, cross-ice passes, the distance from the closest defender to the passing lane, the distance from the passer to the receiver, so the length of the pass, the number of defenders within 5.5 feet of the passing lane, whether the passer was pressured, and whether the receiver was crowded.
So with these 6 variables, we test different models, including the GAM and random forest, because we need a tree-like models to handle non-relationship of the data. We choose attribute model over random forest since we were interested in how each feature impacts pass success, but our model have the pros and cons. We evaluate the model using 5-fold cross-validation. And to further evaluate the model performance, we look at the sharp values. You can see from this waterfall plot, only 3 out of 6 variables are significant, with pass pattern having the highest impact. We noted that all 3 variables positively impact the pass success. Next, we broke out how each variable impacted the model. While pass pattern have the highest impact, not all types have the same impact. For example, when you look at the plot here, the cross-eye passes are more impactful than D2F pass, and this makes sense since cross-eye passes are longer and riskier to make. We also notice that the shorter passes, which are represented in purple color, tend to have lower sharp values, meaning longer passes are more impactful for success. Then after studying and optimizing the model, we want to interpret the result by introducing new terms. Expected pass completion probability is a model prediction on pass success. Then we define defender contribution as a difference between the probability with and without the closest defender. Then we calculate the defender contribution above average to compare the defender contribution to others.
Like Christina said, using the model, we were able to make both offensive and defensive metrics. This first graph is the offensive metric on a team-wide scale, and it plots on the x-axis the average expected pass completion probability of that team's passes, and on the y-axis the pass completion above expected, so the residual, the actual completion percentage minus the expected pass completion. And we actually see kind of like varying levels of success from different approaches. Finland, who is all the way on the left, attempted the riskiest passes. They had the lowest expected pass completion probability, but they actually overperformed that expected pass completion, and they won the bronze medal. The US, all the way on the right, attempted the passes with the highest expected pass completion probability, and they slightly overperformed. They won the silver medal at the 2022 Winter Olympics, and Canada won the gold medal. They kind of had a more balanced approach and also overperformed their expected pass completion probability by the largest margin. This next one is the individual defensive metric. It shows the top 5 and bottom 5 defenders according to our model. And kind of like the eye test on this chart, 4 out of bottom 5 defenders in this chart are forwards, so we thought that made sense. Our top defender, to kind of explain how to read this graph, Michel Karvinen, their contribution above average of 0.265 means that on the passes where Karvinen was the closest defender, the expected pass completion probability of that pass was 26.5% lower than all the other passes. So that kind of speaks to how closely Karvinen crowded the passer or intended target and the pass lane. And we actually wanted to see how these metrics show up on an actual play. So we animated a few goals from the power plays, including a goal that Finland scored on Switzerland during the bronze medal game. And we used the player tracking data to plot that, and then included the pass completion from our model. But before I show you the animation, this is what the actual goal looks like. So we kind of see this very uncrowded D2D pass, a D2F pass that gets completed, but then they lose possession. They recover the puck by the wall, bring it back up, and then this very crowded pass ends up in a goal. And so the way that the animation looks is like this. We see the uncrowded D2D pass has a really high expected completion probability according to our model. Then this D2F pass, even though it doesn't look that crowded just because of the type of pass, and we see that the passer is a little pressured, it has a relatively low expected pass completion probability. Then they kind of lose the puck. This pink dot shows where they recover the puck, and then they bring it back up, and the assist. So we see that the assist has a really low expected pass completion probability, which makes sense. It's crowded. It crosses the midline, so it qualifies as a cross-ice pass, and obviously it's near the opponent's goal. And so kind of what we can conclude from these metrics And what we kind of showed from the animation is what the expected pass completion probability actually speaks to. It doesn't necessarily speak to the skill of the passer or how good of a passing team a team is, but rather their decision making, their risk tolerance, their approach to passes during the power play. And the defensive contribution, although it does speak a little more to the defender's skill, it does still depend on the scheme because it kind of speaks to how big of a load or responsibility that defender has on that team's approach to the penalty kill. If there's two defenders that are crowding the passer, if you remove one of them, the closest one, their impact might not show in the model, but we could see that they are crowding the passer and they're having an impact on that expected pass completion. The limitations of our analysis is obviously the small sample size. We only had 26 games to draw from, and we only had player tracking data for a small portion of those games. Finally, the limitation that actually sparks our kind of direction for future work is that we only analyzed the attempted passes, and we want to expand the model to analyze the defensive contribution of all defenders on the ice. And the way we would do that is by seeing the passes that other defenders, other than the nearest defender to the attempted pass, we kind of see what players they're covering, what zones of the ice they're covering, and what passes they're discouraging or defending. And then we can account for that either by simulating that pass and the value of that pass. So we can kind of attribute the value of that defensive action by weighting the expected pass completion of that phantom pass that was not attempted because the defender was discouraging it, either by the expected goals of a shot from where the pass would be completed to, or the value added to the possession by completing a pass into that zone of the ice. That's it.
Fantastic job by students. That was the first half of the students. We're going to take a 15-minute break. All right, we just had lunch posters, so 15-minute break. We'll be back in here 2:35 to kick off with our next batch of student presentations. Thank you again to our students. Woo.